Next, a panel discussion on delivering a biodefense shield. Please welcome the Honorable Dr. Elizabeth Sherwood-Randall, 11th Assistant to the President for Homeland Security, Dr. Ashish K. Jha, Dean of the Brown University School of Public Health, and Dr. Jason Roos, Acting Director of the Advanced Research Projects Agency Health, or ARPA-H. The conversation will be moderated by Dr. Michael McQuade, Director of the Program on Emerging Biotechnology for Scientific Advancement and Global Policy at Harvard's Belfer Center.
Good afternoon, everybody. Welcome back. I'm honored to have the chance to host this next dialogue on delivering a biodefense shield. As the name implies, we're going to focus on the national security aspects of new and emerging biotechnology. So this is the convergence of, among other things, molecular biology, synthetic biology. You have your own favorite term here. But it's also engineered organisms. It's compute in all of its versions, not just the AI version we've talked about today, but high-performance computing, et cetera. It's the ultimate example not only of a highly multidisciplinary field, but I think one of the things you'll hear about today, it's also a really important example of a place where the national security implications and the economic opportunity implications overlap. And so there's a balance in there that we have to be aware of. I can't think of three better people to be a part of this who are going to join me in the discussion. You heard the names. I'm actually going to do a little bit more detail because I think it's important for you to understand the breadth of the number of expertise, amount of expertise we have here. So to my right, Dr. Ashish Jha is a recognized global expert, trusted expert in particular, on major issues impacting public health. He's a longtime leader on pandemic preparedness and response, from his days directing groundbreaking research on Ebola to serving on the front lines of the COVID-19 response, where he led the national and international analysis of issues. He advised local and federal policymakers. And in March of 22, President Joe Biden appointed Dr. Jha as the White House COVID-19 response coordinator, where he received bipartisan praise for his approach, and in particular, as you'll hear today, his ability to translate extraordinarily complex technical issues into something that the public can not only absorb but trust. So Dr. Jha is to my right. Next is Dr. Jason Roos, who is currently the acting director at ARPA-H, an organization he joined in March of 2024. Before that, he was a senior leader in the Department of Health and Human Services Administration for Strategic Preparedness and Response, served as the Deputy Assistant Secretary and Director of the HHS Coordination Operations and Response Element. He was also the Chief Operating Officer of the Countermeasures Acceleration Group, formerly known as Operation Warp Speed. He was responsible for leading the end-to-end coordination, logistics and data systems for the distribution of FDA-authorized COVID-19 vaccines, therapeutics, and home-use diagnostic tests. These are people on the front lines. Prior to HHS, he served as the Joint Program Executive Officer for Chem Bio, Radiological, and Nuclear Deterrence at the Department of Defense. Dr. Roos, thank you for being here.
Thank you.
And then further, Dr. Liz Sherwood-Randall, who served in the West Wing as Assistant to the President for Homeland Security Advisor and Deputy National Security Advisor from January 21 to January 25. Those of you doing the math, that is the entire Biden administration, so beginning to end. In that role, she spearheaded federal crisis management for a wide range of challenges: terrorist attacks, mass shootings, extreme weather events, critical infrastructure disruptions, and she led efforts to strengthen national preparedness and resilience for future threats. She innovated new policies to prevent, prepare, and respond to natural and pernicious biological risks, and to respond to topics including Mpox, avian flu, and the convergence of advances in biotechnology and artificial intelligence. Dr. Sherwood-Randall previously served as the Deputy Secretary of Energy, the White House Coordinator for Defense Policy, Countering Weapons of Mass Destruction and Arms Control, and as the Senior Director for Europe on the National Security Council. So I think we have a very experienced and very thoughtful group of people who have been through a lot of what is important for us today. So I'm going to jump in. I have some questions. The that we're going to start with, and we'll see where the dialogue goes. So I'm going to use first names if that's okay.
Please.
Please.
Ashish.
Yeah.
Everyone's had their lunch break. They now have food in them. It's time to unsettle them a little bit. So could I ask you to talk about what do you see at this current moment that creates new biological risks? How worried should we be, et cetera? Take it from there.
Great. Well, thank you, and thanks everybody for being part of this for this session. So, we have been worried about biological weapons forever in some ways as humanity, but something has changed in the last 10 years. And fundamentally what has changed is sort of three things. One is the advent of CRISPR and other tools that allow us to edit genes, synthetic biology as we heard about, and AI. And that combination gives us an ability to engineer biology in a way that we never could before. Even the Human Genome Project, which got a lot of attention, was ultimately about reading biology and reading biological texts. Now we can write and edit biological texts. And if you look through history, anytime we got good at engineering a basic science, one of the first major manifestations was weaponization of that. So that happened when we became capable of engineering chemistry. That led to the advent of chemical weapons. I would argue that in the 1920s and 1930s, we became capable of engineering physics, leading, of course, to nuclear weapons of the 1940s. And in the last 10 years, we have become quite adept at engineering biology. And it would be, in fact, shocking if some people out there were not deploying this to engineer biological weapons. I'll go one step further and say we know that they are. We know that both state actors are and non-state actors are. And in many, many ways, it is much easier to engineer biological weapons. They can be self-replicating. You don't need massive amounts of it. And the ease with which people can get access to materials. I'm not a nuclear weapons expert. My sense is it's pretty hard to get enriched uranium. It is not hard to get synthetic biological materials, and to use a lot of these tools. So to wrap up, what we are seeing, I think, is an emergence of a whole different generation of biological agents and biological weapons that look nothing like your father's anthrax. They pose a variety of different threats to the human species, and we've got to get serious about both identifying them and countering them.
Liz, I'm going to give you the opportunity to add to that if you want, but I also have a question specifically given your background. So you spent a lot of time focused on preventing proliferation of weapons of mass destruction, nuclear weapons, et cetera. So I want you to sort of help us understand how the revolution in biology, what are the parallels, what are the differences, how do you think about those risks, both with your long-term background and coming out of the role that you just finished?
Thank you, Michael, and Ashish and Jason for joining in this panel. A few other thank yous to Eric Schmidt for supporting the exchange, to the Bajaktari brothers for their leadership of this endeavor, to my beloved friend Stephanie Carter for keeping Ash's legacy alive, and to Julie Park for making all of this happen. It's really great to be here. The lesson you have provided was an excellent summary of the emergence of a new existential threat, Ashish. I'm going to say a few things about what we've heard in the last 2 days that help us to frame this conversation in answer to your question. First of all, those of you who've sat through the last 3 days of discussion have heard about the extraordinary acceleration of artificial intelligences. This technology development is happening so fast we can barely keep track of it. And we have a parallel need for speed to harness it for positive purposes. And that was really the content of much of the discussion, especially with respect to how we support warfighters. How do we capture that benefit and reduce the downside risks of this technology? Yesterday, Eric Schmidt said to us, the AI revolution is underhyped. Imagine that it's underhyped. It's more powerful than the hype suggests. Second, the reality of this technology is that governments do not own it. And one of the most important aspects of the 3 days of conversation here has been the extraordinary interdependence between governments and the private sector in bringing forward the benefits and managing the risks of these new technologies and their convergence. And here I would say actually the balance has shifted dramatically so that the government is very much dependent on the private sector to bring forward the capabilities. We are not, as governments, in the driver's seat. The convergence of these technologies, you've described the emergence of CRISPR-Cas9 and its capabilities. That was something we focused on a decade ago as an emerging platform risk. We now see something far beyond that coming our way, and that is the convergence of biotechnologies, artificial intelligences, machine learning, and engineering, creating what I see as a whole new set of risks for which we are currently woefully underprepared. At the same time, importantly, there is huge upside, and we've heard multiple people talk about that. Sasha Baker yesterday was very eloquent in describing the potential in the healthcare sector. Similarly, we heard this morning from Alexander Wang about that potential benefit. But this team that's focused on national security is really thinking through the question of how we manage the risk associated with the evolution of biotechnologies. Most important, the bar is significantly lowered in the evolution of biotechnology to widespread access to the capabilities, as you've just said, Ashish, to create novel pathogens. And that easily enables the design of novel molecules and organisms which we have never seen before and for which there is currently no defense. So the threat landscape immediately becomes much more diffuse and diverse. That's quite similar actually to what we see in the terrorism domain, and the two converge. You noted non-state actors are potential significant players here. So my assessment is, and this is why I'm spending some of my lifetime working on this creates an existential risk to humanity. And that's why you asked me the question, how does this relate to how we saw the nuclear dangers that arose out of the development of the atomic bombs? Yes, this is a new existential risk. I'll say one last thing. Those of you who sat through the conversation on Monday with Thomas Larson from the AI Futures Project, he depicted a trajectory, various pathways on his slide. And at the top end of the last line of his slide, he indicated that he believed that adversarial intelligences would produce bioweapons. That was where his story ended. And afterward, I cross-examined him about that, and it only reinforced to me the sense of responsibility we have now to address this urgently. Ash Carter promulgated a doctrine of something called preventive defense, which was to get out ahead of a problem before it becomes an existential problem. It's actually modeled on preventive medicine, where you try to solve a problem before it becomes lethal to a human being. And here we must conduct preventive defense efforts to address the emergence of this technological capability in a way that benefits mankind and does not end it.
Thank you. Two things we'll come back for. Jason, I'm going to get a different question of you. I want to come back to talk about so the issue of what we can detect, number one, and number two, in managing, governing, and preventing, how do we think about the economic consequences, the long-term health consequences of potentially cutting off fruitful development, and how we get that balance right. So we'll come back to that. Jason, ARPA-H's mission is about accelerating better health outcomes among some of today's most pressing problems. Can you tell us a little bit about sort of that portfolio in general, but also how that relates to the issue around biorisk, bioprevention, and the overall topic we have here today?
Absolutely, and Michael, and I just want to thank you and the organizers for having me here today, and this great opportunity to talk about this very important topic, one that's been dear to me from my history as well as my recent experience. So ARPA-H was established in the image of DARPA, really with a focus and emphasis on health, and really trying to get after the healthcare space and the challenges that still exist in our healthcare system. Really, industry is either too risky or not, there's not that return on investment focus, or your traditional R&D mechanisms are not going to tackle. And so we have the advantage of being disease agnostic, if you will, and really work across the entire continuum of the healthcare space. And so while we don't necessarily have a direct focus on biodefense per se, I think we can all agree that there are many technologies and capabilities that cross over from everyday healthcare into the biodefense world. And so that's where our emphasis is. And a lot of those are platform technologies that, while they may have a particular use case today for some disease or some healthcare application, could easily be pivoted into the biodefense community very quickly. So just a couple examples of those, and coming back to Ashish, what you said, we're trying to take advantage of the synthetic biology revolution as we're addressing some of these challenges. And Liz, to your point, this is not something that the government can do alone. We have to partner with we have to lean on industry and academia to really get after some of these challenges. So one of these efforts really is looking at medical countermeasure discovery and in particularly protein design. How do we design prophylaxis, whether it's vaccines, antibodies, or other medical countermeasures, to be able to go after families of disease and to be agnostic to the various different species that may exist there. And so more of that sort of universal approach, if you will, which obviously can play a very important part in the biodefense space. So we have a program called APEX, which is very much focused on that. We have a program looking at deliberately developing antibodies, as well as one looking at antibiotics, all leveraging the power of AI and really trying to get upstream and do that rational drug design in a very quick way that you could pivot if you had a threat. Another area that we experience, certainly in the context of COVID, is you may have these candidates, but how do you get through the regulatory process quickly? How do you prove that their safety and efficacy? And in the biodefense space, there's not a lot of where you have to rely on animal models very heavily. There's often not animal models to be able to even evaluate these candidate medical countermeasures. And so we have another program called Catalyst that's looking at doing all the ADME tox work in silico and in vitro, and really taking the animal out of the entire equation so that we could rapidly understand and do the preclinical work that then lends itself to the clinical work. And then lastly, we have an effort that is looking, leveraging AI to explore all of the currently approved drugs and how they may be applied, and the data that's associated with them, and how they may be applied to solving some of the challenges associated with rare disease. There are hundreds, thousands of rare disease out there, and the economics around focusing on any one of those is generally been problematic in developing a suite of solutions. This particular effort, called Matrix, is focused on using AI to repurpose drugs for rare disease, and we've actually seen an example with Pom's disease, where they were able to, a patient that was sick, come up with an alternative cocktail that was able to save them and get them out of the hospital. That same very technology could be used, especially early days of a threat, and being able to repurpose what might already be on the shelf and target that towards a given threat. So those are just some 3 examples of platforms we're working on that have some cross applicability.
Terrific. And there's technical elements to this whole conversation and response, and there are sort of elements related to global cooperation, et cetera, but it's good that ARPA-H is really now in place, focused on that technical development. Ashish, let me ask you if you can sort of ground us all here. I want to talk about the capabilities that we have for surveillance. You can talk about it from a natural pathogen issue, or you talk about it from a man-made risk, but sort of what is our ability today, and what's the infrastructure around that compared to 5 years ago, compared to where we need to be in 5 years? Sort of a general,
Sure.
Help us understand.
Sure. So basic level of biosurveillance is essential, whether you're thinking about man-made threats or you're thinking about natural threats. And I have argued actually quite publicly that the failure of our country to have that in 2020 in many ways was sort of the original sin of our pandemic response that got us going down lots of paths that we never quite recovered from. But we did build a basic biosurveillance system that's largely based on wastewater surveillance, and it works fine for pathogens. If you know what you're looking for, you can still go out there and identify it in the wastewater in many places around the country. And I think of it as very much an analog system, which is I got to know what I'm looking for, and I have to know kind of, exactly how to find it, and then we now have a surveillance system that can find that. So progress from where we were 5 years ago, completely inadequate for where we need to be given the emerging threats that we see. A lot of the emerging threats we see are biological agents that don't have an immediate clinical manifestation. You can infect a large chunk of the population and you will discover its effects in months or maybe even years. You do not want to wait months or years to figure out that this thing has happened. There are a lot of things that our intelligence communities are tracking. There are a lot of things that are going to emerge that we may not be aware of. So you need a surveillance system that is threat agnostic, that can help you identify the unknown unknowns and do it relatively rapidly. And so the first question people ask is this even possible? I think the answer is yes, and I'm happy to explain what the key features of that need to look like. But the second is it is absolutely essential to build, not just because we want to be able to identify it early so we can turn to Jason and say, build us the antibodies or build us the countermeasures, but as a deterrence because our adversaries are fully aware that we do not have this capability. This is not a secret. And they also know that even if we were able to detect it, our attribution capabilities are terrible. The fact is, 5.5 years after COVID landed on our shores, we're still fighting about where it all began. A great sign to our adversaries that we are not very good at attributing, let alone to detecting. So we need to build a system that can do all of that. I think it is possible. It is going to be multimodal. It's not going to rely on one set of data. All of the things that are creating these risks actually give us opportunities for building a bioradar system for our country that will be able to identify these threats early, will give us some attribution capabilities. I think that's going to have a very important deterrence effect, and certainly will be very, very helpful for early response. And by the way, it'll also turn out to be really helpful if we have another natural pandemic.
So let me pull the thread just a little bit more, right? So you spoke about the, let's say, the technical elements. Yeah. You're giving work to Jason and the team. Let's be charitable. Post-COVID, we took a sigh of relief. What's your assessment of the state of the global information sharing network on threats, threat surveillance, threat sentinels? So not just the technical side, but where are we with our colleagues around the world versus where we were before or after COVID? Yeah,
so in some ways we are clearly worse than we were. I mean, the way that it works right now, there was a new Ebola outbreak, let's say, in Uganda tomorrow. If the Ministry of Health was willing to acknowledge it, they will eventually report that up to WHO. And then the way we worked, and again, there were 12 outbreaks of Ebola in Marburg. Marburg is a very close cousin of Ebola. During the Biden administration, 0 of them landed on our shores. That is not random, that is not coincidental. It was really good information sharing, the US jumping in early to help countries stamp out those outbreaks, and working actively with WHO and countries. We have pulled out of WHO. Information sharing has come to a halt. We have a lot of expertise on these topics that we're not able to deploy. So the global threat and our ability to manage it has gotten worse at a time where a whole lot of factors like globalization, economic development, climate change are driving the risks of natural outbreaks much, much higher. And then, of course, the man-made threats that we discussed are going to be quite substantial. And I'll just make the one last point. We need to build a national capability for detecting these threats, but we also have to work with international partners because just being able to do it inside the United States is not going to be good enough.
Thank you.
I just want to emphasize what Ashish just said with respect to deterrence and defense in this context. We would much prefer to play an away game than a home game in detecting emerging diseases. If we get warning from partners, as we did, you described it, we can go and manage that for them in their country and prevent it from coming to our shores. If we have to, we can put in place some constraints around travel to or within the United States, as we had to in certain circumstances. But the dismantling of what I describe as our global early warning network, akin to what we have for ballistic missile incoming attack, that is, we have radar distributed to give us warning, we have basically dismantled that system so that we have much less confidence that we will know early and create that action that will forestall something coming to infect Americans.
Right.
That also, as you've just said, gives notice to our adversaries that we are less prepared from a deterrence perspective, and if an adversary decides to weaponize a pathogen, then they can make the guess that we will be less ready, we are less capable, we are less resilient. So that now puts great pressure on your first point, Ashish. That's where I wanted to end up, is that if we don't get it from overseas, we have to substantially enhance resilience in the homeland. And we heard yesterday from a panel with former Chairman of the Joint Chiefs Dunford, former Deputy Secretary of Defense Bob Bork, about how vulnerable the homeland is. For the first time since the Second World War, once we established nuclear deterrence, we really didn't worry about existential threats. This is a new chapter for us, and the fact that we are naked to it is of high concern. So we have to invest heavily in that. Building of resilience, prevention that will lead to deterrence.
Thank you. I could not agree more. Let me just keep you on the stage for a moment here. So we've talked about thinking about this in the context of successful nuclear nonproliferation, yes, nuclear threat reduction. You've played a big role there. How do you think about what's the same here and what's different in both what we can and can't stop and what we can and can't know? How do you think about that?
Well, for young people in this audience, I will say, and I can't see very well because the lights are very, very bright. When we confronted the challenge of a fissioning nuclear superpower that was about to break apart across 11 time zones and multiple new countries being born, this was an unprecedented challenge to figure out how to reduce the nuclear proliferation dangers associated with the collapse of the Soviet Union. And from that unprecedented situation, we came up with a way to work with our mortal enemy to reduce nuclear dangers and to gather up nuclear material all across the Soviet Union and to take the delivery systems apart and to store that fissile material so that it could not be stolen by a terrorist or used by some other bad actor. What we imagined was actually realized through human ingenuity and hard work. And again, I'll give credit here to Ash Carter, who was a champion of this from the very start and came up with the concept of cooperative threat reduction that led to the Nunn-Lugar legislation that enabled us to do all that work in the early to mid-90s. So I want to say that even though it seems unbelievably hard to imagine how we will manage the challenge and deal with the potential burden this places on a burgeoning private sector proposition that we can revolutionize healthcare, hard things can be done by people who are willing to imagine possibilities, develop a thorough and rigorous plan, and implement it. And here I'll say the impossible can be possible. The most difficult challenge of this, in my mind, is really that this is happening, as I noted earlier, mostly outside of government. The innovation, the ownership of the capabilities is mostly outside of government. And so therefore, from this very starting point, we have to appeal to our private sector partners to join us in this journey, to figure out a way to manage the evolution of these technologies so that we reap the benefits without creating this existential risk in a way that runs away from us. And therefore, I think we need to incentivize norms and practices that will govern the development of these technologies, that will set guardrails against existential risk. That has to happen now. That's why my initial remarks, I said the pace of this change is happening so fast. We can't wait for a year or 2 or 3. We need to be working right now at home to think through what kinds of domestic guardrails we want to put in place, and we have to work with our partners and our adversaries to do the same internationally. And my expectation is it will be necessary to have unilateral reciprocal actions. It may be very difficult to negotiate any equivalent of arms control agreements, as we did at the end of the Cold War and subsequently, but we're going to have to incentivize that by explaining risk and being willing together to take steps that enable us to manage this effectively. Ash Carter said technology is not stoppable, but it is shapeable. And I think this is that plastic shapeable moment in which we all have to act together.
Right. I think I'm just going to pull this one more time, because I think you're saying something really important here, which is that cooperative threat reduction in the biological space is as much about treaty, process, agreement, people. It's not about detecting and stopping large-scale national infrastructure. I mean, nuclear weapons required a certain capacity. It had a certain sort of surveillance capability that allowed us to look at how we were managing compliance, et cetera. Am I right thinking that the problem here is substantially different? That it's really going to be a human issue that we reduce?
I think it is a human issue. However, I think that the resilience efforts that we've just talked about are an element of this equation. You wouldn't necessarily be doing the kind of overhead satellite surveillance of whether or not the Soviets actually cut up their strategic bombers and laid them out on a tarmac for us to see. You would be doing the work so that you have a biosurveillance radar system, and you help others to have that too, so that everyone has early warning, so that you make a common good of this, in which case it creates constraints and incentives.
Right.
So this is a common goods problem, because what happens with biothreats, as we know from the pandemic best of all, is they know no borders.
Right.
They're not going to choose whether to invade us because their government says so. It may be completely out of the bounds of government decision. So we all need to invest in this together.
Yeah. Jason, you talked before about a number of things going on at sort of, I would say, basic platform technologies. Could just riff on this, a little continuation here about technologies that you think are important that we understand globally, both because they may create better health for everybody, they may create economic value, but they also may be something we want to understand from a potential for biological threat. What's in the technology pool?
Well, I mean, I think in general in this space, we've got to push ourselves harder. I mean, that's why we, in part why we exist, but even across the entire ecosystem, we can be doing better. We can really be pushing the boundaries, particularly with the technology that's out there today. I think about our days back fighting COVID, and if we had that bioradar system every time a new variant came up, and we weren't having to wring our hands and trying to understand, well, was this new variant going to defeat the Paxlovid and the Lagevrio and the oral antivirals or the vaccine or the tests? We've got to get upstream of that. We've got to be not relying on the wastewater and people showing up in hospitals, but how can we get further left to understand what really is impacting human health and really get to that early warning, which clearly is a global challenge. But there's some technical aspects to that. How do we integrate this multimodal data across wearable technologies that we have, data we're getting from supply chains, data we're getting from indoor air quality, et cetera? How do we pull all that together? So that's one area for sure. Another area that we're very interested in is the manufacturing.
Right.
So there's tremendous opportunity in terms of enhancing our ability to manufacture, and importantly, manufacture where you need it and when you need it. A lot of our current manufacturing production is very centralized and based on very older technology. How can we push the boundaries of manufacturing so that maybe every hospital in America has the ability to manufacture that genetic medicine that is either going to save a life for chronic disease, or in the context of a pandemic or a threat can instantly pivot, and you now have locally you have that countermeasure where you need it to be. So that's another area that we're interested in that clearly crosses boundaries.
Yeah.
And then the other place is the supply chains. I mean, we see today are continuing to play this whack-a-mole with the latest drug shortage or latest PPE, or whether blood container, you name it. How do we fundamentally change the business model and invest in some of the technology to be able to transform how we think about supply chains, so we have that redundancy, we have that backstop, and we're not a single point of failure all the way throughout. Mm-hmm. Those are just some areas that we're deeply interested in, right, that clearly cross a lot of different boundaries, but I think could be transformative for the next time we're facing it.
I would just add to this is also critical for national resilience, obviously.
Yeah. Right.
To be prepared if we don't prevent, to respond effectively with rapid acceleration of the diagnostics, therapeutics, and vaccines. And you asked about the opportunity for the private sector that we should, and you have emphasized the imperative of not limiting that in some way that's negative in its consequence. There's a huge business out there to be done to create the capability that we're going to need and our partners are going to need, because we are not going to entirely control this. Right. There are going to be things that happen, whether they're naturally occurring or accidental or deliberate, and we've got to be ready.
Well, and I think
I was just going to say, in the economics works, that if you can find those technologies and solutions that have an everyday job that are easily pivoted into when you have a problem, that's the sweet spot. Right. So you're not having to create something new in the context of the crisis.
Yeah, and I among other things, I go to bed worried at night when I listen to people like you.
Sorry.
I do worry that we may be a victim of our own success on COVID-19, that the next time something comes along, the discipline solutions that were so effective, people are just going to be waiting for the pill, waiting for the shot, as opposed to waiting for the behavior modification that may be just the place that we end up with. Ashish, maybe just a slightly change of gears here. Can you talk a little bit both the experience you came out of and then where you are now? What is the state of global cooperation from your mind, either on the technical side or let's call it the bioradar side? Can you talk a little bit about that?
Yeah, so I do think we built up cooperation quite a bit in the last 4 years. As Liz alluded to, and as I alluded to earlier, that has certainly taken a downward step. We saw this a little bit right now. There was something called the Pandemic Accord that just got ratified by the World Health Assembly. The US was not there. It is an effort to do global coordination for the next pandemic. It is I'm just being very blunt about this, it is an accord with no teeth. It will have very little impact. I think the global community and the global health architecture we have had since 1948 of how we deal with cross-national infectious disease threats is slowly but surely disintegrating. I am not at this moment sure that we can rebuild that infrastructure or that institution. And I'm talking about WHO, I'm talking about all the other organizations around it. And so this is a moment where we need to do a lot of creative thinking about what does the infrastructure need to look like. I think technology has changed. One of the big things that people used to talk a lot about was pathogen sharing, that like if a country has a disease outbreak, will they share that with others? That is an issue. That is becoming, as the world is becoming more global, pathogens are flying across the world much, much faster. Like that is no longer the big limiting step of no one will be able to access it. Unfortunately, everybody will have access to the pathogens because these will become global threats very quickly. So there is a moment here to rethink that sharing strategy. Again, I think the idea of building a bioradar system that tracks and kind of builds profiles of what normal biological profile of a normal community looks like, that has got to be done with interconnection. So I'll give you one example. When I was at the White House, we pushed a whole big program around traveler genomic sequencing, wastewater surveillance on airplanes and at airports, that becomes a very good way of tracking pathogens across cities and countries. We have got to do that, but we've got to do that in cooperation with our partners, because if we're doing that but not sharing that information with them, they're going to be much less amenable. So, look, I think we are in an enormously unsettled moment. My personal view is we're not going back to the infrastructure we've had. We've got to get creative about thinking about new ways of doing this.
And it would be interesting, Ashish, if we could appeal to private sector partners to help us in data collection. So for example,
Absolutely.
On your surveillance proposition, what if the major pharmacies, not pharmaceutical companies, pharmacies in this country, the Walmart pharmacy, CVS, Rite Aid, Walgreens, were willing to share data, anonymized, but on a regular basis that we could ingest to see where is something happening?
Correct.
Because that could give us early warning. Why is there a run on certain kinds of medication in a particular area? And what does that tell us about what's happening in the homeland and potentially overseas? That's a way of working with private sector partners, very simple actually, but could give us information. Indicators and warning is what we would say in the intelligence community of something emerging that we need to focus on.
Yep.
Are you working on that, Jason?
Well, we're trying for sure, and I'm smiling because I couldn't agree more. I mean, we've been at this biosurveillance thing for a while,
yeah.
And the idea that the government is going to gobble up a bunch of data, they're going to collect it, and they're going to be able to come up with truth is just, it's not going to happen. We have to find a way to partner with industry and to monetize the data and the information in a way that it's being used. For multiple different applications. Certainly it can help inform, for pharmacies, foot traffic and how to stock their shelves and what sort of things for them
how
to...
How much should be produced.
Exactly. And so I think I couldn't agree more that building those relationships with the private sector to really figure out what is the unique business model and the value proposition that we can share that burden and responsibility. Clearly we have data sets that could contribute. They have data sets that can contribute. Let's do this together.
This has not thus far proven to be monetizable. I mean, the efforts to, for example, produce vaccines in advance of need has had to be stimulated by and supported by the government. We've had to create and keep companies alive in order to be ready. We may need to continue doing that, but the additional question now, given the scope and scale of what is happening, is whether that can change and create a real market that would incentivize cooperation.
Yep.
Can I say one more thing on this? If we had a biological attack on our country tomorrow, a year from now, 2 years from now, somebody would call for a 9/11 style commission to say, how did we miss this? And the conclusion, my view is, would be almost identical to the conclusions of the 9/11 Commission, which is we had all the data, we had all the dots, and we failed to connect them. And that, to me, creates this incredible sense of urgency of, we can actually do these things based on, not perfectly, and it'll need to get better as biotechnology gets better, but I believe we have the capability today, but all of the data is in disparate places, some in government, lots in private sector, some at the federal level, lots in cities, some in academic institutions, some in health systems, and finding a way of connecting the dots without the government is going to gobble up everything and be big brother. I think it's doable. That is the idea behind building this bioradar system. But that would be the conclusion of the 9/11 style commission that would come out a year from now saying, we had all of this, we failed to connect the dot. So if that's the conclusion, we should not fail to connect the dots. We should figure out how we're going to do this.
Yeah, let me take this even further, because I think there's the, how did we not see the threat coming? Alex talked earlier today about all the jobs that are being created in the data side of AI. I think this is an incredible example of the data is there. It may or may not be the world's most complicated AI problem, but it is a data gathering and data understanding problem.
Yes.
The other question is how do I make an assessment of what my ability to respond is? I would like to have, every day on my desk, if I'm at DHS, I'd like to have a red, green, or yellow chart that tells me my mask supply could be okay if it needs to scale up a factor of 10. I like to know what my vaccine precursor supply is, just in case. I think that's another place that we can be looking at. Does that make sense?
It does.
Yeah.
Yeah, no question. And look, part of what we need to do, I mean, it's interesting, one of the things that Jason brought up, that one of the things that we need to get into is this idea of distributed manufacturing. Because one of the failures of COVID, I mean, the early days, one of the reasons people couldn't get tests is because the swabs were made in a single factory in northern Italy that was hit really hard with COVID.
Yes.
Right.
And the entire global swab supply was at risk. Like, that is not the way to manage a global crisis. Count on that factory in northern Italy being in good shape. So the work you're doing on distributed manufacturing, could the hospitals manufacturing their own thing? Yeah, it's cool, yeah, it's innovative. It is also essential for resilience so that you can't knock out a single factory or its workers and hobble all this. So having a system that tracks that, as you said, know how kind of well functioning it is essential. We have not taken that kind of thinking and approach to manufacturing. We need to if we're going to respond to these kinds of threats.
Yeah. And Jason, you talked about this from as she said, distributed manufacturing, but there's also work you're doing on the actual biological processes to simplify new ways of doing development, new ways of establishing sort of deployable precursors in one way or another. Can you talk just a little bit more about that?
Sure. I mean, and I come back to, you know, I look at the early days of COVID, and you know, I was on the DoD side, the leaders there wringing their hands on, you know, what do we do, and whether it's basic training, or deployment operations, et cetera. And then when I moved into the COVID response, working with the White House, you know, how much do we buy? What do we do? There's a lot of questions that the R&D community needed to be able to get answers to quickly to inform the policy and the decision. So we're not arguing over, you know, do we close things, do we mask, all those, you know, fun debates that we have. So I think there's an opportunity here for what I call operational research. What can we put in place to really accelerate the ability to get answers? And they may not be the 100% solution, but is it, you know, we have IRBs and standing IRBs in place? Do we have standard processes for acquiring services and goods in place? Putting these things in a state that you can quickly use them to get these answers quickly. And where I think certainly the AI revolution is going to come into play is all the work that's going on with creating AI scientists and what are those 3 important experiments you need to do to get to that answer. That's an area that we're very interested in. Understanding there's a tremendous amount of investment going on in the private sector, we're looking at what's the right space for the government to be sort of a partner there to really accelerate the ability to ask a very difficult question and really rapidly get to the answer, and as much automation both from experimental design as well as execution.
Yeah, really fascinating. And I'm going to bring back Liz. You mentioned several times now the need for the private sector to be right in the middle of this conversation in ways it is not right now. Can I parlay that into, based on your previous experience on other kinds of threats, what's sort of what's at the top of your priority list for global cooperation, sort of DHS 2 equivalent to ARPA-H 2 equivalent? Where do you think we need to be here?
In my prior experience, the most important thing we could do was have professionals talk to professionals. Take it out of the political arena. And so we need to create enough content. I mean, this is really incumbent on the people who are focused on this emerging threat now, to create enough content that there can be an exchange of information, that we lead. We Americans can lead. I always emphasize the value of our allies and partners in that initial circle of conversation where evidence is presented of a threat. It can be, much of this is unclassified evidence of a threat. There's also a classified dimension. We can do that too if we need to. And to bring the private sector into that conversation at the start. An example of this is when I was at the Department of Energy in the Obama administration as the Deputy Secretary, and I was very focused on emerging concerns about grid resilience and adversarial threats to our energy systems. And our utilities those energy providers around the country were completely unwitting of the threats because all of the information we had was classified. And so we had to go through a process of getting all of the CEOs who were relevant cleared in to be briefed on what the threat was, and then to build a process which was a government, industry, public-private process to work together on a continuous basis to build resilience. And that involves both prevention and response should prevention fail. It was enormously fruitful and it continues. It was sustained through the first Trump administration, it was sustained during the Biden administration. I hope it will be continuing now. But that model of how you bring the private sector into what you are seeing on the classified side is a very important element if you believe that otherwise they will not be compelled to understand why this creates enormous risk for all of us.
Yeah. Jason, just follow on. The ARPA-H mission, who are your fellow travelers around the world on this particular topic? There are lots of things ARPA-H is doing a lot of different ways, but on this issue around biorisk, who comes to mind as sort of the best partners that we have or the best partners that we need?
So all of our partners are
all good.
They're all good. Like all of our, we love our children all equally. I think the short answer to that is innovation, and we don't have a corner hold on innovation. So we see pockets of innovation in the EU, we see pockets of innovation in Asia, we see it even in Africa. And so what we are looking for is engaging with our counterparts around there to really find, in those problem set that we're looking, who's working on that unique little problem set, and really kind of teasing that out and trying to work that together. And that's been our model, and we're finding it's not necessarily in the big players that you would think would typically be at the table. It's sometimes some small organization or some small segment in one of our partners' nations that are working on something that we can play together with.
All right, we're almost done. I'm going to give each of you a chance to, as usual in these circumstances, we talked about a lot of really important things here. What's the most important message you want to leave the audience in a conference or a set of discussions which are incredibly important about the role artificial intelligence can play in both preventing harm in the modern world and creating opportunity in the modern world? So in this overall area of biological protection, biological risk, biological opportunity, what's your main message, Ashish?
Wow. So the main message, I think, is first of all, we are facing an unprecedented threat, an existential threat, and it is easy to underestimate how problematic this threat is. But at the same time, as I have alluded to, I think we have the capability, with AI really at the heart of that capability, of building sort of, to go back to this session name, delivering a bioshield for this country and for the world that can detect these things, that can attribute where it came from, and give Jason and all of our scientists and our agencies a very early start on countering it. And that has two advantages. It creates a substantial deterrence, and second, if people break through that deterrence, it gives us a running start on solving the problem, and that is going to be very, very helpful moving forward.
Jason?
I'm going to double down on kind of the theme that I had mentioned before, is that having been in this biodefense space for over a decade, I can't emphasize enough the importance of, if you want to sustain a given capability, it has to have day-to-day application. It cannot be just something that break glass, sit on a shelf.
Yeah.
So as we think about where AI fits in this space, we've really got to look to what are those cross applications. So as you're building something for routine healthcare, how could it play a role in the threat space, and vice versa? That is the way that we will sustain those capabilities and have them ready when we need them.
Good. It's a threat, but it's also a tremendous leverage in this conversation. So,
absolutely.
Yeah. Liz,
I mean,
last words.
that underscores the extent to which this is a transformational moment, and there's huge potential for positive applications if we channel this correctly. I will just close by saying, Bill Perry, the Secretary of Defense, who Ash Carter and I both served, said as we were tackling that initial problem what to do about all these nuclear weapons in the former Soviet Union. He said, "Liz, the hardest problems are the most worth working on." And that has been my mantra ever since. And I would say for everybody who took the time to listen to this conversation today, this is one really hard problem that is really worth working on. So I hope you will join in the endeavor.
Yes.
Well, let me thank three people for both a terrific conversation. Also, on behalf of all of us who, and my family, we lived through one pandemic, most recent memory. Thanks to the three of you for the role you played. Unfortunately, I'll probably thank you in advance for the role you will play, because the next one, I have to say, I have a reasonable degree of confidence we will be in this position, something like it again. That's not meant to depress you, it's meant to say we have people who really know what to do. So thank you for the three of you, and thanks to everybody for paying attention.
Thank you.
Thank you.